Welcome, and thanks for joining me for this explainer. Today, we're diving deep into the invisible war that's happening inside and on you right this second. It's the constant battle between your body and the countless microbes that want to call you home.
So, let's start with a number. 39 trillion. What is that? The national debt? Nope. The number of stars in some distant galaxy? Not even close. That is the estimated number of microbes living in and on your body right now. Yeah, that's right. You're actually more microbe than you are human, cell for cell. And that massive, bustling community is exactly where our story begins.
You see, before we can even talk about the invaders, the pathogens, we have to meet your first line of defense. This is your microbiome. Think of it less as a collection of germs and more as an entire ecosystem, a friendly neighborhood watch working 24/7 to keep you safe and healthy.
I mean, seriously, think of them as your own personal bodyguards. This community, which can weigh up to 2 whole pounds, forms a living, breathing shield. They protect you by literally muscling out any would-be invaders. They gobble up all the nutrients and take up all the real estate, leaving nothing for the bad guys. They even form a physical barrier over your cells. And this incredible defense system, it starts getting built the very moment you're born and is shaped by everything you encounter.
This whole relationship is a beautiful example of symbiosis, which is really just a fancy word for living together. And most of the time, it's a mutual deal. We help them, they help us. But if that delicate balance gets thrown off, the relationship can turn parasitic. And that is the exact opening a dangerous pathogen is looking for.
So, now let's turn to the villain of our story, the pathogen. These are the microbes that are out to cause harm. And they don't just stumble around hoping for the best. No, they have a surprisingly organized, almost military-style plan of attack.
It all boils down to what's called the chain of infection. Think of it like a 3-step heist. First, the pathogen needs a reservoir. This is its safe house, a place where it can live and multiply in peace. Second, it needs a mode of transmission, a getaway car to get to its next target, a new host. And finally, it needs a portal of entry. It's got to find a cracked window or an unlocked door to get inside.
So, where are these hideouts? Well, they can be in animals, right? Like bats, which we now know are major reservoirs for viruses like Ebola and coronaviruses. They can also be other people, and not just people who are obviously sick. They can be asymptomatic carriers, people who spread a disease without even knowing they have it. Think of the infamous Typhoid Mary. And of course, these hideouts can be in the environment itself, with contaminated water being one of the most dangerous reservoirs on the planet.
Now this is a really crucial point, one that a lot of people get mixed up. Just because a pathogen has broken that chain and gotten inside your body, that doesn't automatically mean you're sick. There's a huge difference between being infected and actually having a disease.
Let me break it down. Think of it this way. Infection is when the burglar has successfully picked the lock and is now standing in your hallway. They're in, but they haven't done anything yet. Disease is when they start smashing vases and causing real damage. The invasion itself is the infection. The damage that results from that invasion, that's the disease.
Now, when a disease does take hold, it often follows a pretty predictable story arc. It kicks off with the incubation period. That's the quiet before the storm. Then you might get the prodromal phase, where you just feel kind of off. The acute period, well, that's the climax, when the illness is at its absolute worst. And then, hopefully, you enter the decline phase and convalescence, the long road to recovery.
So how do we actually track what's going on during all this? We do it by reading the body's signals. Doctors look for objective signs, things they can see and measure, like a fever, your blood pressure, or a lab test. But they also have to listen to your subjective symptoms, the things that only you can feel, like a headache or nausea. It's the combination of those signs and symptoms that really paints the full picture of the disease.
So what makes one disease a mild inconvenience and another a life-threatening crisis? A lot of it comes down to the pathogen's virulence factors. This is basically its specialized toolkit, its arsenal of weapons. It could be spiky proteins that help it latch onto your cells, or it could be powerful toxins it releases to destroy tissue. The better the toolkit, the more dangerous the pathogen.
Okay, so we've seen how a pathogen can cause trouble inside one person. But how does it make the jump from one person to thousands, even millions? For that, we need to zoom out and look at the science of how diseases spread through a population.
To measure the speed of an outbreak, scientists use this amazing little number called R0, written as R with a little zero. It's a really simple idea that answers one critical question.
If you put one sick person into a population where nobody has any immunity, how many other people will they infect, on average? You can think of it as the disease's raw contagion score.
And the differences here are just staggering. Just look at measles. With an R0 of 12 to 18, a single infected person can set off a massive chain reaction. It's wildly contagious. Now, compare that to COVID-19, which is around 2 to 4, or Ebola, down around 1.5 to 2.5. This one number tells you so much about why some diseases spread like wildfire, while others are, thankfully, much easier to contain.
So who are the people tracking numbers like R0 and figuring out how to stop these wildfires? That's the job of epidemiologists. These are the real-life disease detectives, and their science is what stands between us and public health disasters.
You can pretty much trace this entire field back to one guy, John Snow. In 1854, in the middle of a terrifying cholera outbreak in London, the official theory was that it was caused by bad air. But Snow started mapping the deaths, and he saw a pattern, a terrifying cluster, all centered around a single water pump on Broad Street. He famously convinced the local authorities to remove the pump's handle, and just like that, the outbreak stopped. He proved that if you can track a disease to its source, you can stop it.
Today's disease detectives use a specific vocabulary to describe the scale of what they're seeing. A disease might be sporadic, just popping up randomly here and there. It could be endemic, meaning it's always kind of there in the background at a low, predictable level, like the common cold. When cases suddenly spike way above that normal level, that's an epidemic. And when an epidemic crosses oceans and goes global, that's when we have a pandemic.
And these epidemiologists can tell a story just by looking at the shape of an outbreak on a chart. You see a graph with a sharp, sudden spike that falls off almost as quickly? That just screams point source outbreak. It means pretty much everyone got sick from the same source at the same time, just like John Snow's water pump, or maybe some bad potato salad at a company picnic. But a chart like this one, it tells a totally different story. You see those rolling waves, a series of peaks that get progressively higher? That's the signature of a propagated source. This is person-to-person spread. Each one of those peaks is a new generation of infections, showing the disease moving through a community like a ripple in a pond. This is what the flu spreading through a school looks like.
So, after all of that, what's the big takeaway here? From the microbiome that defends us, to the pathogen's invasion strategy, to the science that tracks its every move, the crucial point is this: understanding is our best and most powerful defense. When we know how these systems work, we can spot the weak links in that chain of infection, and we can break them. And that brings us to one final, very important thought. We know of more than 1,400 pathogens that can infect humans. We've seen dozens of new or re-emerging diseases in just the last 30 years. So the question isn't if there will be another outbreak, but when. And with everything we now understand about how these things work, the real question is, will we be ready for it?